Alright, boys and girls, second video I'm recording today because I could not record this video. I was looking like and researching a little bit offline. First, I found out why the fuck the programs with iterations above 256 were blowing up, because basically, and this was really stupid because I was already tired at the time. This is iteration, it's just not properly written. So each iteration of the for loop pushes a value onto the stack. Okay, it pushes the current iteration, like the current I, let's say. And basically the stack was overflowing because our stack only contains 256 possible values right here, right? So if we do something like this, 256 and an empty closure or an empty quote, and if we do that, obviously this is going to overflow, right? But if we do something like this, 256 with a drop inside, this is going to execute, but it's not going to like change the stack because all of the values that were pushed, like all of the i's that were pushed onto the stack, were immediately dropped, right? So that's working. So, and now if I do like 1, 2, 3, 1,000, 10,000, 100,000, so if I try to do 100,000 loop iterations, well, it's still crashed. It's still crashed. So what's the limit in this case? I try to do 1,000. No, it's still fucked. Why is it still fucked? Oh my god, yeah. So 1, 2. I forgot to drop again. So I'm always forgetting to drop. God damn. So 100, 1,000, 10,000, 100,000, a million. Let's try a million. And I do this. You see, it actually worked quickly, super fast, right? So it's nearly instant, and I'm not joking. So if I do 100,000, 10,000, 100,000, a million, so I could try, but it's hard to measure, anyways. So that's the stuff. Yeah. So let's copy this. If I execute that, you see, like it's nearly instant. But I can define a word, like say that, like so, and I can execute a bunch of words in here, and it's like you cannot even see how fast it is. So it's fine. It's fine. So this one is basically solved. Okay, it's like the semantics that we have. I'll have a type checker in the future, and I basically my type checker, like I don't know how I'm going to handle this kind of stuff. Maybe I'm going to warn the user that like this is going to generate a stack overflow or something, but I don't know. But this one is basically fixed, okay, because it was not an issue. The second one, I also found out why the fuck it was blowing up, because once like this works for both the for loops inside words and for loops inside for loops, so nested loops, because we are not jumping over the quote body, and this is true. For example, when we define a word like so, yeah, and we do this, this will get translated into let's say lit 0, lit 10, lit address of the closure, and the address of the closure is going to be like, since we have a bump allocator, is going to be like immediately here, so the closure is going to be defined there. Let's say we have here like, I don't know, dupe, so we are going to have literally a dupe code, then we are going to have this, and this is basically translated into return, and this is also translated into return, right? Oh, and if we have for loop like so, we would have the for loop here. And what is happening is that when we call this function, this w, this word, this is executed, this is executed, this is executed, then this keeps being executed, and we return. And this return is not the function return, is the quote return. So what was missing here is that here we need a jump, and we need to jump over, let's say something. Here we need to jump over into here, right? That's what we need to do, right? And this will fix everything. And our for loop was actually properly well implemented, and we don't need stack frames, we don't need any of that bullshit. Okay, this is actually a really good implementation of for loop, I think. Okay, It still uses this call stuff, yada yada yada. It's still slow because apparently this one takes 16 cycles and whatever. But I also have like one possible fix for that here. I don't know if I'm going to implement that in this video. But yeah, I still like, I already have something in mind to fix that. Okay, this, because like the rest of the for loop, it seems to be properly like fast, or yeah, it's not that slow. The only like possible slow code is this one, this call, right? Everything else is fine. So actually this clean stack should be, so if for begin, for end, yeah, this clean stack should be in here, right? Because I push it either way. So if I call this, yeah, yeah, exactly. So if this gets inlined and I push this stuff there, I still need to clean it. Okay, okay, makes total sense. But yeah, so this is correct. So let's try to fix this, right? We can fix that. Let's do a jump, right? And for that, I think we can do the same trick. So we can write this assembly as it is. And this is actually going to be a relative jump. I think that should work. Yeah, here, this is not GCC, this is GMP. And this one we'll need to take, yeah, it's basically this one, a relative. Jump near relative. Yeah. So is this going to work if I do the following? JMP, I don't know, JMP begin maybe? I don't know if the compiler is going to like that, but you can try. So then you can just add this stuff here, like so. And we also need jump size, yeah. And since we need jump size, we need to add it there. Exactly. Yeah. Like so. And then when, yeah, we basically, yeah, exactly. So this code compilation mode will need to be an array, because we'll need to keep track, because we'll need to backwards patch the jump, because once we start compiling a word, a code, sorry, we don't know exactly how long this shit is going to be. So we need to keep track, like we need to do a mock value there, right? Once you compile this, and then when we reach this, we need to go back and patch it, right? So instead of having this, we could have something like struct I don't know, quotes. Yeah, it can be just quotes. And here is going to be the address of the start of the quote. Do I need anything else actually? So if I, yeah, that I push the start. I don't think I do actually. I think I just need that, to be honest. Yeah. So here, these quotes can have, I don't know how many nested quotes we can have, like let's say 256, I don't know. And here we can have like size t quotes. It can even be an integer, just to prevent any issue with underflows. And here we can for now have this like that quotes count is returning 0. That's fine. Then here, so this, okay, so this is the address, right? And this is the current address. This is the current address. But before we get the current address that we need to call, we need to do the following. So what the fuck do we need to do? if we are, oh fuck, okay. So this is going to have different behavior, I think. So let me just also update this. This is quotes. Fuck, okay, quotes. Go. So if we are in compilation mode, oh, I forgot this. Yes, greater than 0. If we are in compilation mode, we need to do something slightly different. We cannot use the address. The address is already available in bumpy. So let's take that into here, and let's do the following. So before taking the address, we need to do a mock jump, right? We need to do a mock jump, exactly. So let's say quotes count is going to be equal, or actually dot start is going to be equal to this guy. So that's the first one. Then we need to perform the actual jump, right? And this one, I suppose, oh, this one is actually fuck. Okay. Code append and patch I64, and we'll need the code append and patch I32 because the relative jump here, actually, let me put the 32 bit before, because the 32 relative jump, it only goes, yeah, up to 32 bits, right? We cannot do anything. Everything else is far jump. So yeah, and here, how do I guarantee that GCC actually uses this code, this E9 code, instead of FF? I do not know if, all right, let's, okay. That's actually an interesting question, but let me not worry about that for now. So let's say int 32. Oh, I already passed here the patch size. Huh. All right, but yeah, fine, it's fine. Okay. Then, yeah, here I'll need I32, right? And by the way, here I need the I64 version. Do I use this function anywhere else? That's there. Use it there. This one is still I64, I believe. And this one is for sure I64 still. Yeah, exactly. All right, so then in here, we need to do the jump begin, jump size. Here, so we need to, yeah, we need to a mock value. It doesn't matter what the fuck we pass here, to be honest. So we can just put that there, right? Then we need the offset, and that's a great question. Let's just use 0 for now, and here we need 32 bits, right? Like so. Int 32 bit, right? I could even, like, to be honest, I let me simplify this, because the patch size is always going to be 32 bits. So this is making me size of int 32, and here this can be 64-bit, always is fine. So size of int 64, so it's a little bit simpler to use. Okay, so what are all the functions that use this shit? Okay, so this doesn't need to happen. Then this does not need to happen. Neither does this or this. Okay. So we just put that shit there, right? This will always be incremented. But we only want to backwards patch it when, or do we always want to backwards patch it? Like, because if we are immediately executing it, if we are immediately executing it, it means that the previous code already had a return in there, right? So it doesn't need to be backwards patched. And I think we shouldn't backwards patch stuff that doesn't need to, because that's just dead code, right? And having that code just means the code is larger and it will fit less of it in the L1 cache. So yeah, let's just keep this like that, right? So we only care about this, so you can even like inline it like that. So we are only going, oh fuck, but this means, well, this means fuck. Quotes count will only be greater than 0 if we are, yeah, so that's actually not good. So we need to have that in a separate variable. Let's say compiling quotes. Fuck, I cannot type quotes false, and then or quote compilation mode. We can call it compilation mode. Quote compilation mode. And in this case, we actually can swap all of this shit into that, right? Okay, so that does that, and here we will always set compilation mode into true, right? And that should be fine. So we pushed a mocked jump, which I still need to check if it is this one, E9 CD. Okay, right, we need to check this. Then bumpy is already going to be like after this relative jump, which is fine. And we can take this address because this address will be different from this address. We need to take that into account. Yeah, so that should be fine. And then once we get into here, right, we only need to backwards patch it if quotes count is greater than 0, right, we can reduce it, and then we need to take the quotes start address, and this is actually the place that we need to patch, correct? I think so. So I don't even know if this CD byte is going to be in the correct place. Whatever, I need to check that. So that's the address we care about. So let's extract it. So this is the GMP, right? So this is a jump, and here we just need a patch instruction. We don't need the code append and patch. We just need a patch. So we can have a function for patching. We can say code patch, and in here we can receive the destination of the patch, the value, yeah, sure, the value, and with the offset doesn't matter because the destination should already contain, yeah, I guess so. So let's call this code patch I32, right? And this is basically going to perform that thingy. So here destination dash z, Here we can just put value, and that's fine. And here we can just call actually code patch I32. So this is going to be the destination. The value is just this one, and that's it. Okay. But then in here we just need to patch it, right? Okay. So we can just say that we want to patch JMP plus, and here I'm gonna assume that this jump instruction is just 1 byte at like the header, and then the 32-bit value follows it. So we can, but we'll check that later. We can just for now have something like similar to this. So JMP patch offset is going to be a singular byte. Yeah, it's going to be a singular byte. So in here, and this is already a character, so it should work like that, I think. A character, a pointer, the next pointer is going to be 1 byte off, okay. And then the value, so this is a relative jump. So the value is basically going to be the current bumpy, right, minus the jump location, but this motherfucker is going to place us on the jump itself, right? Well, actually, yeah, it's going to place us on the jump itself. So we need, or I think it's correct actually. So if I have my jump here, and then I have like a bunch of code, dup or swap and something, and now I'm currently executing this thread, right? I'm here. I have not appended my return. Fuck, so I need to first append my return. Yeah, first I need to append my return. That's the first thing. And then I need to patch it. Okay, so I'm here, right? My bumpy is pointing at here, I believe, or is it pointing at threads? What does this do? Okay, so this increments at the end. So result is free. Okay, so result is free. It means that I'm pointing at here. So if I do that, so this is going to be 0, 1, 2, 3, 4. If I do this, so this bump is 4, the jump is going to be 0, 4 minus 0 is 4. So when I execute this jump, I'm going to execute it to there. Yeah, I think it's correct actually. I think it's correct, but we will test it in a bit. So if I do this, it should be fine actually. So I can even cast it into an int in 32. Like, to be honest, this is a uint pointer, but we know that this is always going to be less than 64 bits. I think that's more or less it, I'm gonna be honest, but just to be sure, let me do the following. Let me come here. Oh, and by the way, I still need to, yeah, I forgot about this. So here, I need to set this to false. Okay. But here, let me do the following. So for size, well, yeah, it can be size t, I equals 0. I is less than jmp size, I++, and I can just printf that x that with jump begin casted to a string and dereferenced by I, like that. And then I can just print a new one. Right. I just want to see what exactly the, oh fuck, it has EBFFE. What the fuck is EBFE? It's not even one. Oh, it's this one. Oh fuck. Oh, I see. Okay. So the value needs to be greater than 2 to the power 16, right? So what is 2 to the power of 16? 2 to the power of 16, and we can just add 1 to it. Yeah, that's plus 1. Let's see if that forces the thing to do this stuff that we want. Where is it? Yeah, if I do this kind of shit like so, it should now compile as E9, right? E9 CD, I think. Operand size mismatch for jump. Fuck. Okay, by the way, this one, that's okay. Okay, so let's see what the Clanker does. This is a classic Clanker thing. I do that, and this is in my jump, right? Well, I could manually like append the bytes, right? That's also, I don't know why I'm using the GCC stuff, but I want a relative 32-bit jump. So that's the E9 CD. E9 CD. Huh. Late assembler encodes, but the reality is yeah, but I'm just encoding. That I force GCC to compile GMP as a 32-bit relative. Okay. Or I could, at this point, I think it would be just easier to do the bytes myself, to be honest. Because like, yeah. What is it? 1F, jump 1F. Okay, what the fuck is that 1F? I have no idea. Okay. Doesn't work, of course. I can try that as well. So if I do no op, and then what is it? Oh, it has a label there. So like if I do this, oh, and by the way, this changes. Well, it doesn't change anything, not even memory. EB190. EB, yeah, it's still fucking doing that shit with there. I think I'm gonna start emitting bytes, guys. I'm literally going to start emitting bytes, to be honest. Yeah, because I'm not going to battle with GCC anymore. I don't think so. I don't think so. No, not anymore. So E9CV it is. Let me remove these sheets. And here I can do the following. So if I say, well, I can have something like this: static char that's, and this is basically JMP, and this is a rel32. Rel32. Okay. And then I can hardcode my sheet this in here, saying 0x e9, and then I assume cd is also part of the instruction, 0x cd, and then I have like my empty stuff. So this is 1 byte, right? 2, 3, 4, like so. And then I can like pretend this was generated by the assembler, and I can say that so jump begin is equal well, yeah, jump begin is equal, I don't know what value this would have, but okay, if I say this and I say that jump end is equal to this plus size of that plus 1, because like we want, or do we want, yeah, I think we do, we want the next byte, right, if I'm not mistaken. But we can already check that by just printing gmp size, and you can just do that. So if this is 6, right, because 2 bytes plus 4 for the relative jump, we are correct. Relocation gmp begin, what the heck are you talking about? gmp begin, is it because, oh yeah, okay, okay, so we need to place these ones in slightly different things. Okay, okay, let's say char pointer, let's keep pretending, guys, let's keep pretending that the assembler actually allows me to do this shit. And so yeah, if I do this kind of shit, assignment to char, why, what are you talking about? Oh, let me do this instead. Okay, so jump size is 8, so that's not what I want. I want actually this, I think. It's still 8, what the fuck? So that's end minus begin. How is it still 8 independently of? Excuse me. Well, in the either way, we don't really need the end. We know the size, right? Because if I do this, this should be 6 if I'm not mistaken. Yeah. I don't know where it took the 8 from. Oh, because these are pointers and the guy is... Huh. Interesting. It's rounding up. I mean, we can actually keep this like that because it allows us to have our code aligned properly. So it's not that bad of an idea, to be honest. It's not that bad of an idea. But then, so this is 8 is fine. Okay, it's 8. We can keep pretending that this shit was generated by the assembler. We can keep pretending. But then this is printing complete gibberish here. Yeah. Why are you printing? Oh yeah, because jump begin is now itself pointer, so we don't need that. We can just dereference it like that. And here we have E9 CD 000 000. But fuck, yeah. If we have our code aligned, this in is 0 at the end, is it this going to be executable? Huh. No, I don't like it. Let's keep, so let's stop pretending. we can stop pretending, and we can remove these jump ends, and we can just say that jump size is not a pretended thing, and it's just that. So this is a non-pretended code, this is the no, this is the non-pretended code, this is a pretended code, and then we define the stuff. Okay. And now we have the stuff that we want. Okay. I guess. Then here, yeah, here we do that without this. And now we are certain that this is an E9, right? Here we can literally even just do code append. We don't need code append and patch because we are going to patch later, so we can do code append, and we can just simplify stuff like that. So we just do code append, and then here we do the final patch. Okay, okay. So if I, oh, okay, let me remove these codes. Where is it? Here. If I define a word that contains a quote inside, like that, literally, and I terminate. So this word has E9. Why does it have E919? Wasn't it supposed to be? Oh, I see why. Because fuck, I forgot that the offset now is actually 2 bytes. I assumed it was only 1 byte, but I was wrong. Yeah, this is 2 bytes. Right. So let's try again. If I define a word that contains this, and that, and I terminate my program, we have E9 CD, then we have the relative address. So 1, 2, 3, 4. Why did it jump so far? Okay, so that's strange. That's actually strange. Why did you jump 19? So 19 in X is like a lot. Okay, it looks like it jumped all the way to the end. Let me do the following. So let me print this thing. I want to know exactly what the fuck you're doing. So jump start bumpy is correct. Then we reduce, then that's correct. Okay. I do that with an empty quote, and I return 25. Yeah. Why did you get, where did you get 25 from? So you started generating here. I saved bumpy there. Then, oh yeah, I see. No, it's correct. It's actually correct because it needs to jump over the pushing. Yeah, I forgot that, like, quotes push their its own address onto the stack. So it should be correct. So we have E9 CD. We have that jump. This stuff is the literal pushing, right? This entire thing. Yeah, it pushes, and then we have C3 for the actual quotes, and then another C3 for the words, right? So this is the entire quote. This stuff is the entire quote. Well, actually, this is the quote, and this is the part that skips the quote. So if, for example, I have a word that pushes 42, or actually, yeah, you can push 42, then you can open a quote, push the number 69, close the quote, and then push, like, 420. If I execute this word, I want to see on the stack the number 42, the address of the quote. I do not want to see 69. I want to see the address of the quote and then 420. So, okay, I could remove that actually because this may be a bit confusing. Did I remove that code? It's here. Okay. So let me just retry. It's not that confusing. So I define the same word. If I execute it, okay, fuck. So it's okay. What's the literal stuff begins with a move, I think. A move absolute, or is it a... Oh, it starts with an add q. What other instruction starts with an add q? Dupe. So if I do that, and then dupe, and then I can terminate. Okay. And then I do so the empty one is 19, right? So if I do this, that. Okay. So E9CD is the jump. Then we have 1, 2, 3, 4. Then 4983 C4. Okay, this is the literal. This is the add. Okay, then this 49BD, I know for sure that this is the 49BD is opcode for the moves one, I think. Yeah, either this one or the other one. So this does add Q, move Q. Okay, so yeah, it's the move absolute. And then we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18. Oh yeah, it is jumping. Yeah. So the jump needs to execute. Yeah, so I need, yeah, fuck. Okay. So 19 minus, exactly. So here it's that minus jump size. Okay, minus jump size. Because I cannot like go over, because the jump is already there. The jump is the one executing, right? And the start, this start includes the jump. So I need to subtract the jump size there. Okay, so if I do this like that, this should not, fuck, it still fucks up. Huh. Why? Okay, let me print f that, and if I print this, oh yeah, this is a size t. Let me cast it into an int 32 actually, just to be safe, and I need to cast it there as well. So if I do this, we get 19 again. Oh yeah, 19. That's actually supposed to be 19, because I want to jump. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah. The body of the quote has 19. So why is this segfaulting? Do I have this opcode wrong? Is that what's going on? Okay. So let's ask the Clanker. Find why this program is segfaulting. Faulting. The relative jump seems to be correct, but we'll check. So let's see what the Clanker says. Oh, it's actually quite long. Is off by 1. Use search format and print the debug value. Use bump jump minus jump size, but the rel 39 for E9 must be target next instruction. Oh, target minus jump address. So my target, okay. you are patching, you are using jump patch of 2 and jump size equals 6 because jump rel has 6 bytes. So you patch at the wrong offset and what? But why doesn't it need a CD? Doesn't jump rel 32 need the CD in the opcodes? Huh. No, the rel 32 for near is a single byte opcode. Okay, 0xE9 followed by the CD you showed earlier is just an example of a low byte. Oh fuck, so I've been reading this shit incorrectly. Oh, that makes sense. That makes sense. So it's just 1 byte. Okay. So I did a mistake of patching the wrong place. And well, I was patching the correct place actually, but because I had 2 bytes there, but yeah, so my jump rel 32 cannot have this shit here. Okay, and my bump stuff already points at the next instruction, if I'm not mistaken, so it should be fine. Let's try this one then. W, that's is still 19. Yeah, because it makes sense being 19. Okay, and if I try to execute this, that's okay. It didn't crash. It didn't crash, and the stack is okay. Everything is fine. Everything is fine. Okay, so let me remove that printf here, and now let me redo the actual stuff that I wanted to try before. So if I define a word that pushes the number 42, it contains a quote that pushes the value 69, followed by the literal 420. This on the stack I expect, of course, argc@v, then I expect 42. I expect the address of this sheet, not 69, the address of this sheet, and then I expect 420. Yeah. So if I execute it, okay, we got 1 address, 42, 420, everything is fine. Fuck, let's go. So this should fix like this already fixed the stuff inside definition. So we should already have for loops working inside words. So I can say words with for, let's say something like this, and this word is going to loop 10 times, is going to drop the index, very important, we must not forget to drop the index, otherwise we're going to have stack overflow. It's going to drop the index, and then it's going to push the value 69 onto the stack. Okay, and then we're going to do for, bam, bam. If I now call words with for, fuck, it's still fucked. Why is it still fucked? Can I do applies? So if I do W and I have a word 69 and I do apply, yeah, okay, so the thing that is fucked is, oh, I see, because now, no, it should be fine. Wait a minute. Wait, did it actually work? I don't think, yeah, fuck. So my jump actually needs to go after the literal. Fuck, okay. So I compiled it wrong. I compiled that shit wrong. I need to do this afterwards. So my address is actually equal. This address is the same here and there. Okay. So I only need to patch it afterwards. Okay, so let's try again. What was the example I had? Okay. So let's go with a simple example. The word that pushes that, and then does apply. It still sex faults. Why? What the fuck? What if I don't do apply? What if I just do this? 69. That's okay. Okay, at least it pushed something. But why is it seg faulting now? So if I do that, let me not define it. 69. That's okay. It pushed shit onto the stack, but if I do that and I apply, maybe it's a bug with apply now. No, it's work. So apply is not working inside definitions as well. That's very strange. That's very odd. What's wrong with apply? I don't think apply does anything like weird. So apply takes the top of the stack, puts it into temporary variable. Yeah, it basically does a drop, right? Saving the top of the stack. And then, yeah, it moves it. Why the fuck? Let's ask a Clanker again. Why apply in the in non-compilation mode works, but it fails inside word body when the word is called. And I can provide examples actually. They should be in here. Yeah, I can provide everything. Like so. Because when you compile a word, you inline its machine bytes into the word's body. Yes, that's what I do. But you lose the caller's register-based stack layout expectations. Apply relies on R14 holding a function pointer temp on R12 conventions at call time. When apply runs from an inline context inside the compiled word, return address and register saved layout differ. Why? That's not true. End up returning into the middle of the compiled word or into garbage. So the CPU performs a normal call into the primitive which has its own prolog free code that assumes the caller places R12, R13 correctly, and the call red bar will restore RIP to the caller instructions. I don't understand what it's saying. Inside a compiled word, you sometimes inline. Okay. Sure. Inlining the apply primitive copies its bytes into the compiled word but leaves the call instruction that applies does a call, calls the quoted function, then its own right will pop a return address that points into the middle of the compiled code or into the. I don't understand what the fuck it's talking about. Don't inline primitive perform nested call. Make to its primitive implementation. But I don't exactly understand why it is bad to inline. No, it's completely incorrect. This is an hallucination. This is a complete hallucination. it shouldn't make any fucking difference. And apply, what the fuck does apply do? So this one, this call, okay, it calls that. Apply just does that. So what the fuck is going on? Well, that's the same as saying that if I have a word that pushes 42 and a word like word 2 that calls words, and I can even have a word 3 that calls word 2. If I call word 3, I have 42. But what this guy is telling me is that inlining, let me think about it. So apply, if I inline apply, now it should be fine, man. It should be fine. Change apply to preserve, restore stack registers and jump back correctly when in lines. Convert apply to be a sequence that does not use call rate for its inner call. When inlining compiled words, word bodies, ensure you adjust any internal ret instruction or remove trailing rets. I don't fucking understand. Oh, this one you mentioned. But I only copy this. I don't copy that. Let's see. Let's actually confirm that. So if I do that, that, and then apply. So this one, oh yeah, first it does that stuff, then it needs the E9. So this is the jump. Okay, so this is the apply. Wait. Oh, it's, yeah, I forgot to add the reds. Let me just add the red so I don't. So this is the return. So it's the same thing. So where was it? Fuck. So E9, 1, 2, 3, 4. So this shit is the apply. Actually, this shit is apply. From the machine codes, explain exactly why inlining apply is correct. Simplest safe fix is 1. Disable inlining for apply and any primitive that performs a call rates marks such as word compilation modes. You always emit. No, I don't fucking need it. So add queue. This is so here I have the delete, right? Let's just make sure that it is not. So yeah, add queue, move apps. Everything is fine. Then I have jump +1 because it's jumping above the reds, right? Yeah. Then I have move. Then what the fuck is it? Is apply, I think. Yeah. Move Q, sub Q. Yeah. Then call. Exactly. Then reds. That reds is a red from the function. The inlining sequence begins by emitting the code that's created the code literal and then a jump, blah blah blah, fold. Yeah. That red is the tail of the code creation sequence. You appended red to close the code. Immediately after that red, you copy the bytes of the apply primitive. Why this is broken when inline? Mispaired call red boundaries. The apply sequence contains an inner call R14, which will push a return address R right inner onto the hardware stack and jump to the quoted function. Oh, I see now. Well, function. When that quoted function returns, it will ret to R ret inner, which is the instruction after the call. Exactly, inside the inline apply. That is fine. Exactly, it is fine. After the inner call returns, apply executes its own write instruction. Wait, after the inner call returns, apply to the applies caller. But because apply was in line into the compiled word, the control flow expected by that thread is wrong. The return address on the stack belongs to the compiled word caller. That's not correct. The inlines apply rate will pipe whatever return address happens to be on the what? Fucking hell. You have a jump plus 1 emit before a write. That creates a 1 byte gap, so execution will land on the write when the quote is executed. But then the word containing that inline code is called while call. The stack contains... What the fuck are you talking about? Why it's called stack overflowing? I think it has too much context and it's fucking up things. R12 is being used as a shadow stack pointer. So, okay. This one. Wait. Let me just see exactly what is a complaint. Ah, seg fault. It's actually seg fault. Let's go with seg faults. Because it's a big difference. From the instruction sequence that restores R13 from memory and then calls R14 through an address saved in R13, but the memory, this is because R12 was advanced before the save and then used after the jump. Okay. Copy current 16 into what the fuck are you talking about, man? Okay. I still do not understand why the fuck this is wrong. Fails. Give me a diagram. Man, it makes absolutely no sense. So, unless... So the relative jump... Is it jumping into this red instead of... Well, it makes no sense now. Because if I do this... It cannot be an issue with the reds, I think. Yeah, because this works. And it doesn't seg fault. So it cannot be an issue with the jump itself. It's an issue with the apply. Yeah. It's an issue with apply. So it pushed this a bunch of times. Call pushes return address RA. Address after the call. call a compiled word or apply primitive. Jumps to quote. Quote. R inner quote body. Sure. RA pops R inner returns to apply. Stack timeline top after call. Apply begin. Sure, it makes sense. After apply this call R, yeah. Quote returns. Yeah, that's normal behavior. Sure. Sure. Exactly. Apply bytes inline with into compile unsafe. Okay. After call compiled words, we get the compiled words. Okay. When inline apply executes call, we get our inner and the compiled word. Quote returns, it pops our inner, returns to instruction after call R14 in inline applied. Inline apply executes its ret. Inline apply does not have a ret. For fuck's sake, man. That's the whole point. Inline apply, or does it? Yeah, it doesn't. Because if I do this, bam, bam, apply, bam, there is no ret here. Right? There is no fucking ret. Inline apply executes its ret, pops top of array sub and jumps to RC. That returns from the compiled word back to the caller immediately before the compiled word code finishes. That ret was intended to return from apply. That's not the issue, man. Inline apply does not have a ret. That's not the issue. Find the real issue. I think I'm gonna like go to improved Clanker because this Clanker is too stupid. Sequence into compiled word. You also emit a 5 byte. The patch 32 is computed relative to loads an address that is no longer the actual entry point to the code. Ah, that's true. That's actually true. That's the fucking issue then. That's the fucking issue. So that's the issue. So yeah, because basically, fucking hell, finally, basically, I'm emitting this address, but this address needs to go over the jump, right? It needs to point after the jump. So what I need to emit here is actually address plus whatever jump is the size of the jump, right? We need to call the quotes without the jump, right? That was the fucking issue. I think it took some time for the Clanker to get there. And so, no, it's still fucked. But that was correct, I think. That was correct. But am I jumping to the correct place then? Am I jumping? Let me see. So if I do happen to do something like this, right? And then if I do apply, yeah, so it's fucked. So that's address. Fuck. So don't use with hard-coded address at emission time for literals that will be relocated patched later. Instead, in memory and immediately. Well, that's not really a thing, I think. Right. So the thing is actually with the compilation of the code. So the issue is not with apply by itself. Okay, just do something like this. The issue is not with apply because like the address generated by the thingy, it's actually fucked as well. Yes, that will fix 5 bytes. Sure. But this still doesn't work. Right, that's the point. It just agrees with me. Okay, let me go to a better Clanker. How do I... Okay, I do this. I need to open another browser. Cool. I can do that. Yeah. And now you cannot see my browser. Because this Clanker is a more special Clanker. I'm actually paying for it. So I don't want you to see my account. Why am I getting sick calls when I call apply inside the word body or with, well, I can say but not when I do it in non-compilation mode. It is something to do with the fucking addresses. Like, I think we are generating some fucked up address. Like, but the interesting thing is that, well, yeah, but when we are not in compilation mode, we are not generating, yeah, we are not generating all of this bullshit, so. Let's see what this better Clanker does. Now, this Clanker is much slower, right? By the way, I'm just using Gemini, but it is a paid account. Well, I'm not really paying for it because it's part of my college, but I don't want you to see the account itself. I don't want to be leak anything. Yeah, it's taking some time to even generate. Yeah, you can see that this Clanker is a lot more, I don't know. It should be better, but it sure takes its time. Oh boy, still generating. All right. Damn. The fuck is this guy doing? Let me look at the thinking. Have you finished? Okay. It finally miscalculating bumpy. When compiling a quote inside a word, your code does this. Appends 18 bytes, appends 5 bytes. Oh. Ah, I see. Yeah, fuck. I need to go over the literal and the fucking Yeah, fuck. Yeah, it is correct. So it took its time, but yeah. I need to do this lit size as well. Fuck, how do I know? Oh, it's this one. Okay. Okay. So I need to do this shit. P dot size, because basically, I think it's correct now. I have jump. Wait, I have lit. I have jump, and then I have my quotes, right? And the dress I push in this lit needs to point to here. So it needs to go over the lit and the jump, right? Okay. Let's see now. If I do apply. Okay, it's finally fucking working. Okay, so it was an issue with the fucking get them. It was an issue with the compilation of the actual codes. Okay, but let's try. What was I trying to do? Yeah, the other test. So if I define a word W 4269 then 420, right? So if I do W, I should have that 42, then the, yeah, that's fine. Then if I try to define a word that does basically a for loop 10 times, it pushes the number 69, and then does 4, it does fucking segmentation fault again. But I suppose for different reasons, right? I suppose for different reasons. So if we do this, okay, that's if I copy this, let's ask the Clanker again. I'll need to open the browser again. This Clanker is much better than the other ones from the co. I mean, but it's not like the mini version. It what can I say? Yeah, it now works, but doing for inside the word keeps breaking. Let me give it as many contexts and tokens as possible, because this one is able to actually share them. Yeah, but now it's going to take quite a while. I don't know, guys. I can talk to you maybe. As you know, I live in Portugal, and Portugal has been going through multiple storms. I haven't seen the sun in like 20 days or more. I mean, I'm like, today I saw the sun. It was the first time I saw the sun in like 20 days or something. So it was quite nice. I was able to walk a little bit and yeah, enjoy it. So this sheet is useless. I can show you. Portugal storms 2026. It's probably going to show up. Yeah, see, like it was Christine, and then it was another, yeah, Leonardo, and then it was a bunch of storms. I'm telling you, and it's still, I think it's still not quite finished yet. And but this one got like winds with the speed of some tornadoes, like 200 plus kilometers per hour. Yeah, this shit, 238 kilometers per hour winds. It was quite fucked. But the issue with this kind of shit is that it was one storm after the other, so it was multiple weeks of constant storms. It was crazy, completely crazy. I'm gonna tell you. And then some stuff got flooded and everything. Yeah, lots of stuff got flooded and stuff. But yeah, so the Clanker is still sharding, by the way. I'm not joking. I can take a look at the thinking. Oh Jesus Christ, this thinking is super long. Oh, I see. I see. It's from the thinking I can already see one bug. So this one actually needs to be below the label because this one is going to jump there and it needs to execute this. So I don't think this is the issue itself, but it is a bug in fact. So if I do that, I don't think this is the issue. Yeah, this is not the issue, but it was a bug. All right, it finally finished. But it talks so much. Okay, the problem is that your other stack. I already tested it. It could be that I have the incorrect. Yeah, I'm probably cleaning this incorrectly. I don't know if this should be cleaned. RSP. So I push 8, 16, 24. It should be fine. Yeah. Okay, it thought for such a long time. Wait. Ah, I see. Yeah. I can have a label like for loop ends. Yeah, and put this shit here because this still needs to execute. This still needs to execute always, and here it should be there, right? But still, it's probably not going to fix it. Yeah, this Clanker also was not able to. This Clanker was. I don't think this actually fixed it, but 69. Bam, 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 bam. If I see that, well, it actually fixed it. So the issue was. Well, I don't actually see it. Let me see. So it copies that, it executes that. Oh yeah, this yeah. Well, no, because this is going to jump there. Oh yeah, but it was jumping there. It was skipping. Okay, I see. I see. So without this label, it was jumping there and it was keeping it. Yeah, but this is always going to return, isn't it? How the fuck does that work? Because if I copy, oh yeah, but I'm copying all of this, I'm inlining, so this is not being copied. And when this jumps into there, it is not going to execute the return, it's going to execute whatever was appended to the byte string. Yeah. So if I finish this, I get the index plus the number 69 everywhere. Okay, let's try something a little bit cleaner. So we can drop the index, we can push 69. If we do this now, what the fuck? Why? What? Huh. That's actually very strange. That's not expected behavior, I would assume. I'm dropping, then plus. Huh. So if I do, I don't know. Let me try it actually in the immediate mode. So if I drop, then 69 and 4 m. Ah, fuck yeah. But it should be okay. Yeah, this one worked. So why dropping there fucked it up? Okay. Let's try it. So W 0 10 drop 69 like that. W. I finish. It's oh fuck. Okay. I forgot the for loop. for them. Okay, W. No, yeah, it worked. Why didn't it work before? What the fuck did I do? Oh, I forgot to execute. Okay, yeah, that's why okay, it's working. Actually working. I forgot to execute. So we can now let's try nested loops. So if I loop from 0 to 2, and I do push the number, I don't know, 420, I can drop the index, or I can leave the index there. Well, let's first do this. I do then, I can drop the index, then I can do it from 0 to 5, and I can push the number 69. This should print, well, I can drop the index again and then push the number 69. This should print, this should actually push to the stack 10 69s, right? It didn't. Oh, because, fuck, I forgot. I need to call for twice. Otherwise it's not going to work. So this is the inner for, and it's the outer for. Okay, so nested for loops still do not work. Alright, so let me wrap this into a function. Yeah, let me wrap this into a function so we can debug the codes. Actually not me, but the compiler. The compiler node with the Clanker. Nested for loops are still not working. Let's see what the Clanker does now. One more year waiting for the Clanker to do shit. Like, people generally say that like the cost of LLMs is a race to the bottom. I've heard this sentence multiple times. But once you actually start using it and you actually like on your daily job start programming and building agents with this kind of shit, you quickly realize that there's no such thing as a LLM cost race to the bottom, because LLMs with as time moves forward consume more and more tokens. Sure, the tokens can get cheaper, but the point is how much tokens does an agent or an LLM require to perform a job, right? And the really complicated jobs that are quite simple for humans, let's be honest, but let's assume they're complicated for machines. They require such an absurd amount of tokens that there is no such thing as a cheap agent, right? So I don't know, man. I don't know what these guys are thinking, but maybe they are right. Maybe I'm not seeing the big picture, but I don't know. I really do not know. All right, it's still thinking. Look at this. It just has produced like, I don't know, at least 100,000 tokens of thinking material. It is still thinking. It is not even started to the debugging process. So far, it has only been understanding what's going on in this code. Yeah. I mean, I think I provided the correct thing, haven't I? Yeah, I did. So that's 02, it drops the index, pushes 05, it drops the index, pushes 69, it does this 5 times, and does this 2 times, so this is going to be executed twice, right? Yeah. I think it's okay, but It is still thinking. Okay, so it started to identify. Oh yeah, it's the issue. Okay. From the thinking, I can already see what the fuck is going on. So here, that's false. But if this is still greater than 0, we still need to set it to true, basically, right? Right. We can do it here. So counts is greater than 0, and it is always true. Otherwise, it is false. I think this is what it's complaining about. But let's go check it once again. We can copy this code. We don't even need the function. Yeah. L is still the segmentation fault. So let me see what the clanker said. Premature compilation exit. Yeah, sure. It patches. Yeah. Yeah, that is true. Yeah, but it's still not. It is still not working. Okay, let's give it one more try. I don't even know how long I've been recording. No, 1 hour 32. I know this may be like super boring for anyone watching, but I really do not want to leak the models that I use on a daily basis. So let's keep it like that. Well, we can even try to figure out if the DuckDuckGo version can. Why not? When I run nested, well, we can pick another model. Let's go back to the or Mistral. Um, Maybe this one. When I run nested for loops, I get a sec box. I can provide that, and I can provide this sheet as well. Why not? And I can also provide. I feel like I need a disassembler, because without the disassembler, I really rely a lot on these clankers to convert the machine code into something that's more readable. But so the other clanker has already finished. When the compiler eats the inner that, yeah, it could be. So it's now suggesting that instead of having this, I could have like a quotes depth, because of like the immediate mode and the non-immediate mode. It could be that, but I mean, it's something with a fucked up address again, like for sure. I'm like jumping into the incorrect like some fucked up address and it's blowing up shit. Let's try that. So quote depth. Okay, it's at this, and so here like you can check. Yeah, if it's greater than 0, it's fine. And then here quotes depth is going to be incremented always. Yeah, for sure, it's always going to be incremented. Here I append that. Here to check if it has a jump. Like this is the same thing. I don't know why I need quote depths, to be honest. Because it is suggesting exactly the same thing. Maybe it's not the same thing. Well, I think it's exactly the same thing. So this one, this time it didn't actually, it wasn't actually able to debug anything at all. Well, it actually worked. So what's the difference between the, well, because this one is only, yeah, okay, I can see it. Because the first one does not increment this shit, right? Then it goes there, it increments, but at this time, okay, it's incremented. Then it does that and it patches. But then because it was 0, it left the compilation mode, so it started doing this shit outside of the compilation mode, and it fucked up. Okay, I can see. Yeah, and we basically got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 69s. So just to make sure, this one is fixed as well. So let's try to have a few examples. So this is a normal for loop. Yeah, we can even say it's like this. So this one is going to put all numbers from 1 to 9. Let me just close this browser. All right. Then we can have nested for loops. Can say something like this, and then we can drop that index, and then have that, and then that, and then that, like so. We can have nested for loops. We can have for loops inside functions, or inside words in this case. So words with for, let me use this. Okay, and if we get like 5, and this does a drop and pushes 69, and then 4, and if I call word with 4, this should work. And of course we can have nested loops inside words. So word with nested for, and here let's say I want this, and I don't know, 5, 5, or even like 2, 5, 420. I mean, and we can have like as many nestedness as we possibly wish for, right? So that should work everywhere. So if I do this, and then I pipe this, so if I do cat example.f and I pipe it to main, and I do that, okay. So we get all numbers from 0 to 9. So this is the first one. So we get a check. It's okay. Then we get all numbers from 0 to 9 again, but multiple times. So it does that a bunch of times. Okay, so that's fine. Okay, and we can even check if that's true. So these ones, so it should be like 100 numbers if I'm not mistaken, right? So if I do this, let's just double check. Bam. This should be 100 lines. Okay, it's 100% correct. Then we should have 1, 2, 3, 4, 5 69s. So this executed correctly. That's okay. Then we have the index plus 420s, and this should be a bunch of them. So here you can see that the index went all the way up to 4, and then it reset it and went all the way up to 4 again, right? And that's okay. And all of this code was compiled into this small amount of machine code. Yeah, so we have everything working. We have for loops, we have words. The only thing missing, I think, is the well, I can save them. Okay, this one is like an optimization. I don't think we need it right now, so this is optimization. But it's a lot more important to have conditions. So like ifs, and the if can work like this is the true branch. This is the false branch, right? And here we can have like the bool. We can have something like this. So if this is true, this is executed, otherwise this is executed, and everything is consumed from the stack. We can also have like a variation of this that just has a singular stuff like that, and we can say like the same as factor. So factor is a when keyword. I can show you. So when is like an if but without an else. Exactly. It just has a single quote. What else do we want for conditions? Let me check. We can even get inspiration from conditional combinators. Well, we could have unless, I guess. That's also okay, but this one I don't even know what the fuck it is. Let me check. So x, oh, okay. Okay, so if star does not consume x, basically. Well, why do you need... Oh, okay. The cond value if it is true. So cond is preserved if it is true. Okay, so I don't think we will need that. Then we have this alternative, which... calls cond on the default objects. Okay, I don't really care about this. So they only have this, well, combinators which abstract the nested chains of if. This can be actually useful. So, oh, but for this we need arrays, right? We need arrays. Okay. So we can implement that when we have arrays. And that's another thing that we should implement in this language. So the arrays, 1, 2, 3, pushes the address. No, this is actually like this. That's right. Or is it? I don't even know. Of the array into its stack. But like in the if, or we can have like a bump allocator for data. We can also have like that. We don't have it right now, but we can have bump alloc for data will contain. So it's going to contain something like counts followed by this stuff, right? It's going to contain this kind of data. What else? Does it make sense? Let me see what factor does for the case. Well, it has this stuff. Okay. Sure. Sure. So we really don't need that right now. So I think this is the next focus, to have like these conditions we can implement in the next video. And arrays also is very important. And I think that with this plus arrays, we already have quotes. We can add a few more primitives. And I think we will have a pretty reasonable language. Then we do like a minor optimization, because this is already quite fast. Like dupe only takes 2 instructions, and these instructions are super fast. The only thing that is actually not that great is this call, but it's also not the end of the world, to be honest. And besides that, this code is already very well optimized. We can like maybe squeeze a little bit more performance out of it. But for like a single pass compiler that aims to be as simple as possible, and it aims to like have a small code footprint, I don't think it's that bad, to be honest. And I would, after implementing this very basic like kernel language with some basic functionality, I would actually want to implement something in this language and actually use it and understand if it is good or not, right? Or we can implement the type system. We can put a type system on top of this. That's also an option. I don't know. I need to think about it. But yeah, that's enough for this video. Thank you for watching, and I'll see you in the next one.